Today we start a new chapter in which we will be graphing some quadratic equations. And so to start with, typically we figure out whether a point is on a graph or not. And so it's the same thing when we found out whether a point was on a line, but now we've got a different type of equation. This is called a quadratic equation, and they're quadratics when we have the highest exponent on the x value is a 2. So you notice how we have a 2 here, and that makes this what we call a quadratic. And so we're going to end up doing the same thing that we would do typically on a problem where we're asked to figure out whether this point is on the line, and that is to substitute. And so we're just going to take the x value and the y value and put them in place of the x's in the equation. And then also, we'll take the 5 here, which is our y value, and put it in place of the y. And if it does equal, once we do the substitution, the evaluation, then we'll say yes, it is. If not, then we'll say no. So we go ahead and do the work there. We got 5 equals 1 squared plus 4 times by 1. And what this is really doing is not only helping us figure out or to be able to prove whether a point's on a line, but also to work on some order of operations. We're going to have to use this when we're graphing, at least on tonight's homework. And so we bring down this 5. Here we square first, so we have 1, and then we multiply, so we have 4, and just so happens the two numbers, 1 and 4, do make 5. So this is a yes, because the two numbers equal each other. So let's take a look at the next one. Same thing. Now, when we have this minus sign here, this is the same thing as saying negative 1 times by x squared. Whenever you have a minus sign in front of a term, you can always write it this way. And it's important to think of it this way because order of operations says we don't multiply first, we do exponents. So exponents are done first. So that will modify the answer if you end up putting this negative 1 here multiplied. Otherwise, you might think of it as a negative 1/2 squared, and you'd end up with the wrong sign. So now we'll go ahead and do that substitution again. X is 1/2, y is 3/2. So we'll do that work by putting those numbers in place of the variables and seeing what we get. And so now we've got our y value is now 3/2. Our x value, well, it's 1/2, so it's negative 1 times by 1/2, and so we're going to square that number, and then plus 2, and we'll see what we get. So we go ahead and do some more work there. When we square a half, it's the same thing as doing 1/2 times by 1/2, so notice that makes 1/4. And so we have negative 1 times by a fourth plus 2. Well, and multiplying a negative 1 times by a fourth just makes a negative 1/4. Now I got to add 2. So I'm going to modify 2. See, I'm going to think of 2 as 2 over 1, and then I'm going to multiply it so it has the same denominator as the fraction I have here. So I'm going to multiply it by 4/4. So that makes an 8/4. So notice how I modified that fraction. And when I do that subtraction, I do not get 3/2. I get 7/4, which is different than 3/2. So those two numbers do not equal, so that would end up being a no. So when the numbers don't equal, it's no. If they do equal, then it's yes. One more problem to practice again, it's just substituting. So I've got our x value here, we're going to put in place of x. Y value, put in place of y. So we'll go ahead and rewrite what we've got, remembering that the 1/2 is being multiplied by x squared. So we've got a square first, then we multiply. So when we do that squaring, we end up with a 4, positive 4, because it's two negatives being multiplied. And so then we have to take half of 4 next. And so when we do that, we end up having a 10 equaling just 2 plus 8. And now we can add the 8 to the 2, which does equal the same numbers we have on the left-hand side. So this one is a yes. So the first few problems will have those directions. The next few problems ask us to graph. Now, we'll have various different types of equations. Some will just have one term, and some will have maybe two terms on one side of the equal sign. And so what I would recommend to start with, and we'll figure out another way to graph later on during the week, but for right now, since we don't know what it looks like, what this graph looks like, let's go ahead and just make a chart. Now this is the way I make the chart. I pick some x values, and then I plug them into the function. And remember, a function means that when we plug in an x value, we're always going to get the same y value when we plug in that number. And so we go ahead and pick some values. Now, for right now, let's go ahead and just pick these numbers for tonight's homework. Let's use -2, -1, 0, 1, and 2. So those are the numbers we'll use tonight. And so we go ahead and plug those numbers in. So it's -2 in for x. So try doing some of this work in your head. 1/2 times by, and then -2 squared makes 4. And so whether it was a -2 or +2, you're still going to get 4. Half of 4 is 2. So that ordered pair is x comma y. Remember, x comes first. And so we write that as -2 comma 2 is that point. So I go over to my chart here, over 2 spaces to the left, up 2 spaces. Gives me that point. And then we'll go ahead and do the next one. And I'm going to go ahead and give myself a little bit more room. It looks like I'm scrunching these numbers together a little bit too much. So let me rewrite this -1 here. And when I plug in the -1, I end up having still that 1/2 times by, and then -1 squared is just 1. So I end up with 1/2. So my ordered pair would be 1/2 comma, and then we have, actually, sorry, here we have -1 was our x value, so let's rewrite that. So we have -1 comma, and then our y value was 1/2. So we go ahead and plot that point over -1, and then up just 1/2 space. So not quite on those two lines, but in between them. And so let's pick 0 now. And so we'll go ahead and plug our 0 value in for x. And when we plug in 0, it's nice because everything cancels out. So we just end up with 0. So 0 comma 0 is that number. So it's going to be right here. And then when we go ahead and plug in the 1, for x, we have 1/2 times by 1 again, because we end up having to square 1, and 1 squared is just 1. So we end up with another 1/2. So 1 comma 1/2. So you can see the symmetry that's forming here. See, now we go over 1 and just up 1/2. And then the last one was 2. So we go ahead and plug in the 2, and we have 1/2 times by 4, because when we go ahead and square the 2, we get 4. Well, 4 times by 1/2 just makes 2, so 2 comma 2. So you can really see the symmetry now, because when we go over 2, we go up 2. And now what we have is what we call a U-shaped graph. And this one we call a parabola. And so when we have this U-shaped graph, and we're going to get that U-shaped graph with any kind of quadratic, when we have that 2 as the exponent on the x, we're going to end up with this shape of a graph. So let's take a look at those last two problems. Here we have another one in which we have a parabola. We know it's going to be a parabola because it has this x squared. So let's go ahead and make our chart. So we've got our x values. We've got the function, -x squared plus 2. Now, when we have that -x, let's go ahead and change this a little bit to make it a little bit easier for you to see. That -x squared means that it's -1 being multiplied by x squared. And then we get our y values. All right, and then we know what the ordered pairs are. We'll be able to plot those. So let's just use the same point, starting with -2. So do some of the work in your head. -1 times by 4, because -2 squared is 4, and then plus 2. So this makes a -4 plus 2 makes -2. So we're going over 2 and then down 2 spaces. And then over here, we'll try -1. When we go ahead and plug that in, it's -1. Now again, this -1 came from the original function. But then -1 in for x, that squares and makes a +1, plus 2. Well, -1 times 1 makes -1, plus 2 makes +1. So over 1 space to the left, up 1 space. When we plug in 0, it's nice because it'll cancel out the exponents and the multiplication, just making 0. 0 plus 2 makes 2. So over 0, up 2 spaces on our graph. And then we'll pick 1, and 1 is we're getting the same answer here because you look, -1, we brought that down, times by 1 squared is 1, plus 2, notice it's the same as this one right here. And so we end up with the same answer, 1. So over 1 space to the right, up 1 space. And then when we plug in 2, we go ahead and bring down that -1 times by 2 squared, which is 4, plus 2. Notice it's the same as when we plugged in -2, because when you square a negative or square a positive, you get the same answer. You get a positive. And so when we go ahead and do that work, -4 plus 2 makes -2. So over 2 to the right, down 2 gives us another parabola. But this one is facing down. Notice it's facing down. So this one opens up, and the other opens up. This one opens down. Let's see if we can figure out why it opened down. Well, looking at this negative sign in front, we always took the opposite of what we squared. So that might give you a hint there. Let's take a look at the last one, though. And here, again, we'll make our chart. We've got x, and then our function, x squared minus 5, and then our y value. And so kind of think about which way this is going to, what it's going to look like, and which way might it open. And so taking a look at the first number we'll try, -2. We go ahead and plug that in, square -2. This time we get a positive 4. See, 4 minus 5 gives me -1. So over 2 to the left, down 1. Plug in -1. -1 squared makes 1. 1 minus 5 makes -4. So over 1, and then I go down 4. 1, 2, 3, 4. And then if I plug in 0, nice thing about 0, it cancels out any exponents or multiplication of those exponents. We're just left with that -5. So over 0, we just go down 5. And then we have 1, and notice what happens. When we square 1, we get 1. 1 minus 5, it's the same as what we had right here. We get a -4. So over 1 to the right, down 4. And then when I plug in 2, square 2, I get 4. Minus 5 gives me -1. So over 2 spaces to the right, and then down 1. And notice what we have here. We have another parabola, because it's an x squared term. But this one opens up. So what do you think causes it to open up? See, here when we squared the number, we had to multiply by a negative. Here we squared the number, we multiplied by just 1, or just a positive 1. And so think about that and how that relates to which way it ends up opening. We'll explore that more in the next part.